Hello! So I have two questions for you. The first one, what is the probability of flipping a coin and the coin landing on tails? The second question, what is the probability of flipping a coin 3 times and the coin landing on tails every time? 3 times in a row. The first one is pretty intuitive. You can probably guess. Think about it, think about what your answer is, and we'll talk about it in a second. You're probably right. So for our first question, what is the probability of flipping a coin and the coin landing on tails? I've written up here probability of tails. You probably have a pretty good idea about this already, but I'm going to go through it. The probability of tails is equal to 1/2. This means that it's not likely and it's not unlikely. We have a 50% chance. I'm going to write down here also 0.5. 0.5 is the same as 1/2. That's our probability, is equal to 50%. So we're going to do an experiment here, and this is to look at the probabilities. And first I want you to just understand what we're doing. I'm going to release one of these little red bouncy balls, and it has a 50% chance of going left, and it has a 50% chance of going right. It's going to bounce down through this little maze, and randomly it's going to end up somewhere. This is a random process. It's just going to bounce, 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 bounce. We don't know where it's going to go. Sometimes it goes to the right, sometimes it goes to the left, and the probability of going left and right is 50%. So this is just like our coin toss. Our coin toss has a 50% probability of going one way, and it has a 50% probability of going the other way. Right now I've set this up so that we only have one trial and go left or right, and we have a 50% probability. So I'm going to let this run. Now half are going to go to one side and half are going to go to the other side, or more precisely, about half are going to go to one side and about half are going to go to the other side. So far we've let this run a little over 100 times, and we have 54% that are going to this side and 46% that are going to the other side. As we let this run, we would expect that as these numbers get bigger, 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 these would get closer and closer to that 50% mark. It's a random process, but as the numbers stack up, we expect that somewhere about half are going to go to the left, half are going to go to the right, and right now we're at about 51% and 49%. So we're calculating what is the probability of flipping a coin 3 times now and the coin landing on tails every time, 3 times in a row. So I have up here the probability of tails, 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 which we're going to calculate. So looking here, I have the probability of tails, tails, tails is equal to 0.5 times a 0.5 times a 0.5. Now looking at that, we can put that in our calculator and we should get something that looks like 0.125. Now, why did I put 0.5, 0.5, 0.5? Each time we have a 50-50 chance. This is 1/2. 0.5 is 1/2 in each of these. So multiply those all together, 0.125. Now we remember, how do we convert this to a percentage? This is equal to a 12.5% chance. So that if we were to do this, say, 1,000 times or 100 times, we would expect that 12.5% of the time we would get tails, tails, tails. This would be, say, heads, 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 and tails, tails, tails. Now, mathematically, we've worked out what we think the probability is going to be, but experimentally, it's probably going to be a little bit different. Let's go ahead and see. There was a tails, tails, tails. there was a heads, heads, tails. So as we go through here, we're going to expect that this column over here is going to approach that value that we had computed just a little bit earlier. So I'm going to let that run, and we're going to check back here in just a little bit. So why does this happen? Why is it the case that we get this 12.5%? We've looked at the mathematics. 0.5 times 0.5 times 0.5 does give us this 12.5%, but let's look at it a slightly different way too. We could flip the coin tails, tails, tails and get tails every time, but that's not the only way that the coin could fall. Looking here, we could have tails the first 2 times, and then we don't get it the next time. We could have tails, skip 1, and then get tails again. There's a lot of different combinations, different ways to get tails. We might get tails only once. We might get tails at the beginning, we might get it in the middle, we might get it at the end. There's a lot of different combinations here, and of course, all the rest of these are going to be landing on the other side of the coin. They're going to be heads. So we've let the experiment run. We've let the experiment run 1,000 times. So I'm going to let one more little ball drop. We're not sure where he's going to go. It's going to be a random process. One more little ball. He went over there. So each one's random. Each time this probability will change. Out of 1,000 ball drops, we had 122 that went over to this side, or out of 1,001. So I'm letting all the little red bouncy balls drop, and as we get more and more and more, we would expect that it's going to approach this ideal. That 12.5% of them are going to go over here, 12.5% of them are going to go over here. I just want to say thank you to the University of Colorado at Boulder for creating this neat little probability model, and we'll see you at the next video.